Never interrupt someone doing what you said couldn't be done. Amelia Earhart. Today we're going to get into aviation weather, and here is the battle plan. We'll start with a short scenario. You'll have the opportunity to share what you've learned about gliders. We'll get into aviation weather, and then we'll do a quiz and assign some homework. Here's the scenario. You're maneuvering at 10,000 feet when your buddy starts acting goofy and belligerent, and when you try to talk, he barely makes any sense. What might be going on? This might be a sign of hypoxia. There are a couple different reasons why he might be hypoxic. First of all, if you're maneuvering, pulling really, really hard on the stick or doing some abrupt maneuvers, the blood might be pooling at his legs, and he might be experiencing stagnant hypoxia. That's where the blood pools at your legs and it can't make it up to your head. Also, because at higher altitudes, the barometric pressure decreases, there might be less oxygen for a pilot to breathe. So there are two reasons why he might be hypoxic in this situation. Now's a good time to review gliders. Also, if you want to go take a look at your fuel system in your pilot operating handbook, get familiar with your systems. It'll make you a much better pilot. Let's get into weather. Wind shear. Wind shear is a sudden change in direction of the wind, and it can happen at any altitude, either vertical or horizontal. It's common when the temperature inversions when the wind speed at 2,000 to 4,000 feet above ground is 25 knots or greater. You can expect hazardous wind shear in areas of low-level temperature inversions, frontal zones, and clear air turbulence, and especially under thunderstorms. Right? We saw it in the last video. If you penetrate the bottom of a storm, you might actually have a headwind at first, and it might shear to a tailwind and drag you down to the ground. Wind shear, not fun. Let's talk about the temperature, dew point, spread, and fog. First of all, what is the dew point? Well, here, the dew point is the temperature where the air becomes saturated with moisture, essentially. And when the air temperature is within 5 degrees Fahrenheit of the dew point, you can expect things like fog and low-level clouds. Remember that the air temperature determines how much water vapor can be held by the air. Frost is not fun. It can actually degrade our performance and our lifting capability. This happens when the collecting surface is below the dew point of the adjacent air and the dew point is below freezing. This is when there's a direct sublimation of water vapor to ice crystals. So it goes from vapor to crystals, and it completely bypasses the liquid stage, or the liquid phase, excuse me. Water vapor becomes visible as it condenses into clouds, fog, or dew. And evaporation is the conversion of liquid to water vapor. Sublimation, like we said before, is the conversion of solids to water vapor and water vapor to solids. So if there are 3 stages or 3 phases of matter, there's the solid, liquid, and gas. Sublimation is when you skip over the liquid phase, or going from vapor to solid or solid to vapor. So let's review. Where may wind shear occur? At any altitude, vertical or horizontal, and especially in temperature inversions when the wind speed at 2,000 to 4,000 feet AGL is 25 knots or greater. Where might hazardous wind shear be expected? In areas of low-level temperature inversions, frontal zones, and clear air turbulence. What is the dew point? That's the point at which the temperature, where air has 100% humidity. I like to think of it as the point at which air becomes saturated with moisture. What determines how much water vapor can be held by the air? Air temperature. Which of these is the conversion of liquid to water vapor? Is it sublimation? No, it's evaporation. Nice. Which of these is the conversion of solids to water vapor or water vapor to solids? Is it evaporation? Nope. It's sublimation. Nice. All right, let's talk about the different types of fog. There's radiation fog, advection fog, and upslope fog. We're going to start with those 3. Radiation fog, or shallow fog, happens when there's clear sky, little or no wind, and there's a small temperature dew point spread. Now, radiation basically means that the ground is radiating. So think of like a radiator. So it's going to cool the air directly above it and form low-level clouds or fog. as opposed to advection fog. Advection happens when there's motion or a light breeze. So the air is going to go over a cold ground and turn into fog or visible moisture. Now, which of these requires little or no wind? Is it advection? No. Remember that advection includes a lot of movement, and then radiation is the one that has little or no wind. Let's talk about upslope fog. This is warm, moist air being cooled as it's pushed up a mountain slope. And then there's precipitation-induced fog. This is where warm rain or drizzle falls through cold air. The evaporation from precipitation saturates the cool air and forms fog. This is associated with fronts, icing turbulence, and thunderstorms. Then there's steam fog. This happens a lot in the winter as cold, dry air passes from the land over warmer ocean water. It's composed of water droplets that often freeze quickly, and it is associated with low-level turbulence and icing. So describe upslope fog. That's when warm, moist air is being cooled as it's pushed up sloping terrain. And now describe precipitation-induced fog. That's warm rain or drizzle falling through cold air, and the evaporation from precipitation saturates the cool air and forms fog. Remember that it is associated with fronts, icing turbulence, and thunderstorms. Now describe steam fog. This happens mostly in the winter when cold, dry air passes from the land over warmer ocean water. It's composed of water droplets that often freeze quickly, and it's associated with low-level turbulence and icing. Let's talk about clouds. There are 4 families of clouds. There are high, middle, low clouds, and clouds with extensive vertical development. So here we've got the high, middle, and low clouds, and then the clouds with extensive vertical development. They are named by kind of how their appearance. So stratus clouds are very long and stretchy, pulled out clouds. Cumulus clouds tend to be fluffier clouds. So if you see something like stratocumulus, that is a long, stretched out, fluffy cloud. Nimbus or nimbo usually has to do with rain. So a nimbostratus cloud is a long, stretchy cloud that has rain. There's altocumulus. Alto is usually associated with middle clouds. So altostratus is a middle cloud that is long, stretchy, and pulled out. An altocumulus cloud is a middle cloud that is fluffy. Cirrus is associated with high clouds, so cirrus, cirrocumulus, cirrostratus. Cirrocumulus is going to be high altitude, fluffy clouds. Cirrostratus is going to be high altitude, stretchy clouds, and then cirrus is just these wispy clouds like these. Then there's these clouds with extensive vertical development. So you've got towering cumulus. This is kind of like the first stage of a thunderstorm. Clouds with extensive vertical development, and then the cumulonimbus cloud here. That's that giant cloud. Big fluffy rain cloud. So that's essentially how we name our clouds. So let's review. What about these stretchy clouds? That's stratus. How about these stretchy clouds with rain? Nimbostratus. How about these fluffy clouds? Actually, I think this is a stretched out and fluffy cloud. So yeah, stratocumulus. All right, middle clouds. Remember what prefix we associate with middle clouds? Typically alto. So long, stretchy middle clouds are altostratus. And then middle clouds that are fluffy, altocumulus. High clouds have the prefix cirrus. And high clouds that are fluffy, cirrocumulus. And high clouds that are flat and stretchy, cirrostratus. All right, first stage of a thunderstorm looking guy, it's a towering cumulus, and then this big guy here, big fluffy rain cloud, cumulonimbus. You got it. Remember that the greatest turbulence is in cumulonimbus clouds. And like I said before, towering cumulus are the early stages of a cumulonimbus, and they are indicative of convective turbulence. Remember that nimbus means rain cloud. So nimbus means fluffy? No, of course not. We just said it. Rain. Got it. Oh, let's talk about the lapse rate. So typically as air rises in a convective current, it cools at a variable rate between 1.2 degrees Celsius to 3 degrees Celsius per 1,000 feet. We typically use the 2 degrees per Celsius as we figure out the change in temperature as we rise. Remember that the dew point decreases by approximately 0.5 degrees Celsius per 1,000 feet. And so again, for simplicity, we use 2 degrees Celsius per 1,000 feet for our adiabatic lapse rate. Let's talk about the stability of air masses. Actually, let's go back over here and talk about this. What does this actually mean? Basically, we say that we can figure out generally where our freezing level is given our temperature at the surface. A typical day is going to be 15 degrees Celsius at sea level. And so if we cut that in half, that's 7.5. So we know that the freezing level is going to be at 7,500 feet. If we're trying to figure out if 15 degrees Celsius here at the surface, we're trying to find out at what point 0 degrees Celsius is. It's 2 degrees per 1,000 feet, so about 7,500 feet is going to be our freezing level. So you can use this rule of thumb essentially to figure out where your freezing levels are. Hope that helps. All right, now let's talk about stability of air masses. Stable air has these characteristics: stratiform clouds, they're flat clouds; smooth air, kind of hazy, poor visibility, and continuous precipitation. As opposed to unstable characteristics, they're going to be fluffier clouds, cumuliform clouds, turbulent air, and good visibility, and then showery precipitation. So remember, if you can think of like thunderstorms are going to be, fluffier clouds, cumulonimbus clouds. Those are going to be associated with unstable air. And then stratiform clouds are going to be, these flat clouds. This is going to be much more stable air. When air is warm from below, it rises and causes instability. So if you see cumulus clouds, you can kind of assume there's going to be turbulence underneath them, right? Like we said before, the lapse rate is the decrease in temperature with increase in altitude. And if the lapse rate is greater, or the change in temperature is greater, the air is more unstable or less stable. You can use the lapse rate, the actual lapse rate, to determine how stable your air mass is. Moist, stable air moving up a mountain slope produces stratus-type clouds as it cools. So like we said before, if you see stratus clouds, that's typically associated with stable air. So if you have clouds forming, if you've got stable air moving up a mountain slope and it becomes stratus clouds, you can assume it's stable air. If you see turbulence and clouds with a lot of vertical development, then you can assume that's going to be unstable air, right? So let's review. Are these characteristics of stable or unstable air? We got stratiform clouds, smooth air, fair to poor, continuous precipitation. What do you think? Stable air. Steady precipitation preceding a front is usually indicative of a warm front. And you see we've got these stratus-type clouds here, and it's going to be steady precipitation. So yeah, that's going to be a warm front, like we saw in previous videos. This results from the warm air being cooled from the bottom by colder air, and it results in stable air with stratiform clouds and little or no turbulence. So a warm front coming in, it's going to be associated with stratus clouds, very flat kind of clouds, and steady precipitation, and typically stable air. Let's talk about temperature inversions. Normally, the temperature decreases as altitude increases. An inversion happens when the temperature increases as the altitude increases. So it's going to be warmer air than you'd expect. This often develops near the ground on clear, cold nights when the wind is light, and it's caused by terrestrial radiation. Smooth air with restricted visibility is usually found beneath low-level temperature inversions. So smooth air. Let's review. Steady precipitation preceding a front is usually indicative of what? A warm front. Yeah. Okay, so that covers our main topics today. Take 5 minutes if you want to jot down what you can remember, and then let's get into our quiz. Ready? Hit it. Where does wind shear occur? at all altitudes and all directions. If the temperature dew point spread is small and decreasing and the temperature is 62 degrees Fahrenheit, what type of weather is most likely to develop? That's fog or low-level clouds. What is meant by the term dew point? The temperature to which air must be cooled to become saturated. Clouds are divided into 4 families according to their height range. Which marking identifies the never exceed speed? That's that red radial line. What is a characteristic of stable air? Stratiform clouds. A stable air mass is most likely to have which characteristic? Poor surface visibility. When there is a temperature inversion, you would expect to experience which of these? Yeah, by definition, an increase in temperature as altitude increases. The airspeed indicated by points Alpha and Juliet is the normal stall speed. Thunderstorms, which generally produce the most intense hazard to aircraft, are squall line thunderstorms. Crests of standing mountain waves may be marked by stationary lens-shaped clouds known as standing lenticular clouds. In which environment is aircraft structural ice most likely to have the highest accumulation rate? In freezing rain. What is the crosswind component for a landing on runway 20 if the tower reports the wind as 220 at 30 knots? That's 10 knots. The suffix nimbus used in naming clouds means what? A rain cloud. If 50 pounds of weight is located at point Z and 100 pounds at point Y, how much weight must be located at point X to balance the plank? £50. Every physical process of weather is accompanied by or is a result of heat exchange. With the airplane loaded as follows, what action can be taken to balance the airplane? Make sure to pause the video here and knock out this question. Add a 100-pound weight to the baggage compartment. How long does the airworthiness of an aircraft remain valid? As long as the aircraft is maintained and operated as required by the Federal Aviation Regulations. What is the expected fuel consumption for a 900 nautical mile flight under the following conditions? Pressure altitude 6,000, temperature 5, manifold pressure 20.4 inches of mercury, wind calm. If you need some time, go ahead and pause the video. 65.5 gallons. If there's thunderstorm activity in the vicinity of an airport at which you plan to land, which hazardous atmospheric phenomenon might be expected on the landing approach? That's wind shear turbulence. All right, that knocks out our quiz. Go ahead and review. Go keep reading the Airplane Flying Handbook, the Pilot's Handbook of Aeronautical Knowledge. Here's a website for you to do practice quizzes. Definitely keep testing yourself. And then next week I'll post the next video. If you have any feedback for me, I'd love to hear it. And here are my references. Thanks for watching. See you guys next week.